Hi folks, we're going to take a look at page 106, number 18. So they ask us to show that the tangent to this curve at the point 1, 3 is also tangent to the curve at another point. Okay, so if you notice here, 1, 3 is on the curve because if I put in 1 here, I get 1 squared. 1 plus 1 is 2, minus 2 is 0, cubed is 0, plus 3 is equal to 3. So this point is on the curve, and they're saying that the tangent line to this curve at this point is going to be tangent to the curve at a different point. Okay, and we'll draw a picture afterwards, but I would say even before I do that, let's actually figure out what the tangent line to this curve is at 1, 3. All right, so we already know the point that we're working with. We just need to find the slope of this line, which of course is going to be given by the derivative evaluated at x equals 1. So let's start by finding the derivative. So y prime is equal to, I'm going to use the chain rule here. So this whole thing in the bracket is my u, so the derivative of u cubed is 3u squared, so 3 times x squared plus x minus 2 all squared, times the derivative of u, which is this function in the inside, which is just 2x plus 1, okay? And then of course I have plus the derivative of 3, but that's just a constant, so it's equal to 0. So let's now find y prime at 1, all right? But I notice here that 1 made this whole expression inside the bracket equal to 0, and this expression also shows up as one of the factors in the derivative. So in fact, this is just going to be equal to 0. So we're actually looking at a horizontal tangent. All right, so since the slope is equal to 0 and it passes through 1, 3, it means that my tangent line is just going to be equal to y equals 3. It's just going to be the horizontal line that has to have this y value, which is y equals 3. So if we try to reason out what's going on here, so if I draw myself a little picture, so at 1, 3, okay, this curve has a horizontal tangent, so it looks something like this. It just means that's, so if I just kind of draw my horizontal tangent, it means that at some other point, there's also going to be a horizontal tangent. So this is our goal, is to show that there exists another point for whom y equals 3 is its tangent line. All right, so let's find the other places where the derivative is equal to 0, because obviously if they share this tangent line, the rate of change has to be the same there. So I'm going to take my derivative and set it equal to 0. I already know it's equal to 0 at 1. Let's see where else it's equal to 0. So instead of writing it all out, let me factor this thing here. Okay, because I've got a bunch of multiplications equal to 0. I'd like to factor the whole thing. So I've got 3. So here, this factors quite nicely. It's just going to be x minus 1. Okay, and again, these two things are squared, so squared, and then x plus 2. And of course, it's also going to be squared. And then, of course, times 2x plus 1 equal to 0. All right, so we have 3 possible values where this function could be equal to 0. So we have x equals 1, which we already know. That's the one we already found. But it's also equal to 0 at negative 2 and at negative 1/2. So all we have to show is that the y value at one of these points is also equal to 3. Okay, but I think if you think about it, you should be able to tell which one it is based on this expression, but let's just check it. Let's check x equals negative 2. And if I stick in negative 2 here, what do I get? I get 4 minus 2 is 2, minus another 2 is 0, 0 cubed is 0, plus 3 is 3. So y at negative 2 is also equal to 3. Okay, so that means that at the point negative 2, negative 2, 3, okay, tangent is also, is also y equals 3, okay, because the slope is 0 and it passes through the point negative 2, 3, so it must be this horizontal line here. All right, so just to recap, step number 1 is they asked us to figure something out regarding the tangent to the curve at this point. So the first thing we did was to actually find the equation of the tangent. And then we reasoned out that if at another point it needs to have the same tangent line, it must also have the same slope, in this case here 0. And then we determined which of the values in fact gave us the exact same tangent line, which turned out to be at -2. Okay, that's it for this one.